Welcome to clickmeproject.com. Let me discuss about the process, a statistical modeling approach for tumor-type identification in surgical neuropathology using tissue mass spectrometry images. Let me discuss about the process, a statistical modeling approach for tumor-type identification in surgical neuropathology using tissue mass spectrometry images. So in this process, tissue mass spectrometry is used, and for that some specifications were given. So we done that process using the tissue images obtained. So initially the tissue images were pre-processed using median filter. Then after that the features were extracted from the tissue samples using the GLCM algorithm. So the GLCM algorithm extracts the texture-based features from the image. So the co-occurrence matrix is referred as a co-occurrence distribution. Is defined over an image to be distribution of the co-occurring values at a given offset. It represents the distance and angular spatial proportion between over and base of region of the specific size. GLCM is connected from a grayscale images. GLCM is calculates how often a pixel with a gray level value occurs either horizontally, vertically, or diagonally to other adjacent pixels with a value. Then after that the selected features were extracted from the obtained features. So for that difference evaluation feature selection algorithm is used. So we are selecting the particular features from the best features from the extracted features, and then we are classifying the images using the KNN classifier. So KNN classifier is a simple classifier. So we are giving the true label and the test image features and the training features into the classifier, and the classifier classifies the images into normal and abnormal based on the true label and the testing training features that we have given. Let me see the flow of the process, a statistical modeling approach for tumor type identification in surgical neuropathology using tissue mass spectrometry images. Initially, the input images is pre-processed. For pre-processing, we are using median filter. Median filter is a non-linear digital filtering technique often used to remove noise. Such narration technique is a typical pre-processing step to improve the results of the digital processing. Median filtering is widely used in all the digital image processing. Then after that, features were extracted from the images. So here we are extracting the texture-based features such as GLCM algorithm. A co-occurrence matrix also referred as a co-occurrence distribution, specifying over an image to be a distribution of co-occurring values at a given offset, represents the distance and the angular spectral relationship over an image for the sub-region of the specific size. GLCM is treated for a grayscale image. GLCM is calculates how often a pixel with gray level value occurs either horizontally, vertically, or diagonally to adjacent pixels with the value. Then from the extracted features were selected. So for best features were selected from the extracted features. For this we are using a differential evaluation feature selection algorithm. Then we are classifying the images into normal or abnormal based on the KNN classifier. So for KNN classifier is a non-parametric method for classifying objects based on the closest training examples in the feature space. In KNN, the function is only applied locally, and all the computation is referred under classification. KNN is never algorithm is one of the simplest of all the machine learning concepts. So using that, we are classifying the images into normal and abnormal. Let me see the running procedure of the process, a statistical modeling approach for tumor type identification in surgical neuropathology using tissue mass spectrometry imaging. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get a GUI window which contains all the user interfaces which is required to run the program. So select the train datasets button. So the tissue sample images presented in the datasets were trained by extracting the features, GLCM features. Then give any one of the input image which is present in the dataset, and then they are pre-processed. Then features were extracted from the input image, and then the selected features were extracted from the images using DEFS algorithm. Then the image is classified as normal, and then analysis is done. So here we are calculating the confusion matrix. So in the confusion matrix, so this represents, so in this category, so we are having so this represents the 2 negative, 2 positive values in the images like that. So here we are calculating the up to 6 images values were displayed, and for representation is set. So this is process of the thank you.